Today we generally celebrate the brilliancy of scientific achievement by awarding what's known as the Nobel Prize. And one of the more recent Nobel winners is the iconic physicist Roger Penrose, who was awarded the Nobel Prize in Physics for his work on black holes and the general theory of relativity. But at the same time, Penrose is also known for proposing several ideas and several explanations in the field of cosmology that are not entirely accepted by everyone, with one such idea being in regards to the Big Bang and to the cyclical nature of the universe. And so today I actually wanted to discuss some of the most recent studies in regards to the nature of the universe and in regards to the idea known as the Big Bounce, or the idea that the universe is cyclical and that following the Big Bang and following a really long period of time, it repeats again, and then again, and then again, and many times for infinity, with some of the more recent studies kind of doubting that, and specifically doubting this mathematically. And so here I wanted to discuss some of these ideas in more detail and focus on what we know and obviously what we don't know in regards to these concepts. But naturally we have to start with the concept of the Big Bang, the beginning of everything. Although technically Big Bang has never stopped, it's still going on even now. It's the expansion of the universe that's still going on. And the main problem with the ideas of Big Bang today is that if you were to basically retrace yourself back in time, you would find yourself in a kind of a point of singularity, when the universe is super infinitely small and represents a point of zero volume but infinite energy, which we know would be impossible in nature, so it's a kind of a mathematical anomaly. And because in modern physics we also have the idea of Planck units, or the minimal units of time, mass, temperature and length, there's basically no way to know what happened before that one Planck second. This is where essentially modern physics breaks down. But it's also where a lot of quantum effects very likely play a large role, and where ideas like loop quantum cosmology might potentially resolve some of these issues, but these ideas are still in their infancy, and also are obviously not accepted by everyone as well. And so theories like this one do have certain explanations for what might have happened before the Big Bang, and what might happen in the future, very distant future, when the universe is sort of ending. Now we've discussed some of these concepts in the videos you can find in the description below, but the most accepted idea today is what's known as the Big Freeze, or the heat death of the universe, or potentially another scenario sometimes referred to as the Big Rip, when the universe basically just rips apart. Now obviously there's no way to prove this or to actually know what's going to happen, but mathematically that's what the scientists came up with. But one of the, I guess, more intriguing ideas here is what's also referred to as Big Bounce. That's essentially part of the idea of a kind of a cyclical universe. And one of the main explanations from loop quantum cosmology proposes this cyclical explanation. So basically, when the universe was that extremely small point, it actually reached that point by contracting from the previous universe that was much larger, but started to contract in time. Or in other words, following the expansion and the acceleration of the universe, at some point it might slow down and then contract back into the tiny spot just to restart again. Although according to Penrose, you might not even need contraction, and instead the universe can actually go through consecutive Big Bangs and the consecutive expansions, and in between them there is essentially a period of time where nothing happens. It's sort of even more difficult to understand, but it would just basically suggest that the universe keeps going through these consecutive expansions and might have been doing so for an infinite period of time. And first, let's start with the proof, because this is science after all. So a few years ago I've actually discovered this article / paper that was also used by Penrose and several other people trying to prove this idea, with the idea recently republished once again under a slightly different title. And it relates to something that might be visible inside the earliest light in the universe, the cosmic microwave background. So about 10 years ago, the scientists discovered these unusual points in the light, with some of them sort of visible in this image, that today some of the scientists refer to as the Hawking points, named after the iconic Stephen Hawking. And according to these scientists, these represent the remnant signs of ancient supermassive black holes that evaporated long time ago, with this basically being produced by the Hawking radiation from these black holes. Now it's a pretty big statement and it's actually a pretty big assumption, but they do provide some evidence in their study. However, there are quite a lot of other studies refuting this evidence. And they do make a lot more sense as well. As a matter of fact, this study right here you can find in the description does so by providing the comparison with what simulated Hawking points should look like and what we discover in the CMB. They sort of look nothing alike. But these points have actively been used by the proponents of this idea of cyclical cosmology for the past 10 years or so. And so their main point of evidence might not really be that strong after all. But one of the main advantages of these cyclical theories is that they actually explain some of the observations from the cosmic microwave background that did not make sense to scientists right away. For example, there are certain points in here which seem to have come from the same region, but are separated from one another by tremendous distances, which suggests one of maybe 2 or 3 possible explanations. One, the universe could be much older, or possibly even cyclical like proposed by other scientists, and thus could have been actually expanding, shrinking, expanding, or continuously expanding and re-expanding for a long time. Or the more widely second explanation is explained using the idea of inflation, not the same one that we're going through right now economically. We're talking about the sudden and unexplained expansion of the universe in the first fraction of a second, when the universe suddenly increased in size by a huge amount, which was then followed by a much slower expansion that we're going through today as well. But because nobody really knows why it happened, it's not also accepted by everyone. At the moment, there is no physical explanation for why the universe suddenly jumped in size so dramatically. And so in a sense, there are these 2 conflicting theories. Either this cyclical universe is correct, or we just had this one universe starting with the Big Bang, but it had the inflation. I mean, there are some other explanations, but these are, I guess, the 2 bigger ones. And the thing is, both of these models still have problems with them. For the Big Bang model that doesn't have anything before it, well, there's still no explanation for what happened before or what happened at that minuscule point when the Big Bang just started. But for the cyclical explanation, the problem is more mathematical. It's really in regards to this other concept known as entropy. It's a concept that's not as intuitive, but it kind of connects to the idea of chaos. Basically, today we know that the entropy in the universe is supposed to increase in time, and this by definition provides us with the arrow of time. Or basically, entropy defines in which direction the time flows. I mean, I'm simplifying things here quite dramatically, but it would probably require an hour-long video just to explain this in more detail. I've been meaning to produce this actually, but it's really difficult to explain. Anyway, for this video, all you have to remember is that entropy increases with time. And we believe that by the end of the universe, the entropy is going to be really high. But because in the beginning of the universe, the matter was relatively uniformly distributed, the entropy was much lower. And so one thing that's kind of difficult to explain for these cyclical models is how the entropy can then go back to low numbers in order to once again restart the universe. Currently, it's really not believed to be possible, and if the modern universe is just one of many of these Big Bangs, the overall entropy should already be ridiculously high, and in theory should not even exist at all. In other words, the chaos of the universe is not really tackled as well in a lot of these theories. And although some research tried to explain this with a kind of a cyclical dilution of entropy, where the universe does actually return to its original state occasionally, which then restarts the Big Bang, this recent paper on cyclical cosmology mathematically shows us that, well, if so, the universe still has to have a beginning somewhere. It cannot have been cyclical forever. In other words, the scientists here mathematically prove that if the entropy is cyclical and can maybe return to the original value occasionally, there has to be a beginning somewhere, and the cyclical universe cannot be forever. It has to have had a beginning, and it has to have an end. Okay, maybe not the end, but definitely the beginning. And without this, it just does not make sense mathematically. It's the only way to complete the model. But in the end, none of these models provide the definitive explanation, and none of them explain everything. For the cyclical model, the entropy is still a big problem, and the previously proposed evidence of Hawking points is unfortunately not strong enough to actually prove that this is the signs of ancient black holes. In other words, there are no signs of previous universes existing anywhere. These points very likely have a different explanation, something we'll discuss in one of the future videos, so make sure to subscribe. On the other hand, the explanation using the Big Bang and the inflation, with just one universe and no cyclical nature, has its own problems. For example, it's kind of difficult to prove this idea wrong. And it also doesn't particularly have a very good explanation for why exactly this happened. Why did the universe suddenly inflate so much? On top of this, we have the problem of ultramassive black holes existing really early in the universe. The black holes that the scientists believe should not be possible. And now the new evidence from James Webb Telescope also tells us about these early galaxies that have already been developed way more than they should have been. So there are still quite a lot of unresolved issues, and I'm sure we'll be talking more about this as more data comes out and as more evidence is provided. And so I guess as a conclusion, the only thing we know for certain is that we actually don't really know what happened. Or if the universe is cyclical, if it just happened once, how it's going to end, or more importantly, how it began. Which is great news because that means that we're going to be exploring these ideas for many years to come as new theories are proposed, as new explanations are made, and more importantly, as new evidence is discovered using new telescopes and using new techniques. We have to have a new theory, new explanation, and potentially completely new physics that connects a lot of separate ideas that are currently not entirely understood. So stay tuned for more explanations in some of the future videos. Thank you for watching, share this with someone who loves learning about space and sciences, come back tomorrow to learn something else, check out some of the previous videos on the idea of cosmology somewhere in the description or maybe somewhere right there, and support this channel on Patreon by joining channel membership or by buying the Wonderful Person t-shirt that you can find in the description. Stay wonderful, I'll see you tomorrow, and as always, bye bye.